page 63 of your note sheets. All right, everybody with me? And you will see we are finding limits. Now, in the first few problems, I did not use the actual limit notation. But notice that starting with letter F, I used the official calculus notation for evaluating the limits. All these problems are going to be done exactly the same way. I just kind of eased into the notation. All right, we're on the back of page 63 of our note sheets. Everybody's paying attention. Now, I want you to think about the terms of this sequence. Okay, Bryce, what we're getting ready to talk about is like real legit calculus, and I need you paying attention. Okay? I want you to look at the terms of this sequence, and hopefully you see a pattern. These are the squared numbers. So the next term would be 36 and 49 and so on and so on. But that isn't the point of the exercise. The point of the exercise is, does this set of numbers have a limit? In other words, is there like a wall that they're not going to go past? And the answer is no. You're right, Maya McLaurin. There is no limit. And you may write no limit. These terms just keep getting bigger and bigger and bigger. You may write no limit, or you can use the actual math term, which is divergent. You don't need both. You may use either one. Divergent means no limit. If you prefer to say no limit, you can. Now, take a look at the next set of numbers. Now again, if your thinking caps are on, you see a pattern here. I'm multiplying by 1/3, right? By 3 in the denominator, or 1/3. So it's going to be 1/81, then 1 over 243. Now what is happening to those numbers? They are not getting bigger and bigger and bigger like this one is. They're getting smaller and smaller. No, there is a limit. Because will these ever become negative? Will these numbers ever become negative? No, they keep getting littler and littler, but think on the number line. They keep going, 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 but they're never going to be negative. So what's their limit? What's the wall that they're approaching? 0. So the limit for number 2, or letter B, is 0. They'll never go negative. They'll never go past 0. They're getting closer to 0. Would you agree with that? All right, C. Now think about that for a minute. Think about the number line. Here's -2, here's 4, here's -8, here's 16. What's happening? They're flipping back and forth, but every time they flip, what do? Go farther. Is there a limit then? No, divergent. Number 3 is divergent. Now, all the rest of the problems have fraction or ends and stuff involved in them, okay? We actually talked about this very concept months ago when we were graphing horizontal asymptotes. Do you remember horizontal asymptotes? When we graphed the horizontal asymptote, I'm looking at number D. When we graphed the horizontal asymptote of something like that, back when we did it, it was written like this. But it was the same idea. Does anybody remember how we got the horizontal asymptote? Anybody remember how we did that? Patrick?
Okay. The +1 at the bottom
It has been a while. What we do is we look at the highest power in the problem. We actually ignore the +1. And we look at just the powers. what does x over x or n over n, what does that reduce to? 1. So the limit here would be 1. So the answer to letter D is 1, because we have n over n, and that reduces to 1. Look at E. Can you use the same logic with letter E? We have 2n over 3n.
Yes.
So our limit is 2/3. It's the fraction. Reduce the fraction. 2/3. I need you paying attention. Look, wait, time out. Look at F. What's the highest power in the problem? Squared. Compare the squared on top with the squared on the bottom. Reduce the fraction, what do you get? 4/5. The limit is 4/5. Groupies, we only look at the highest power. We don't look at the other numbers. We don't look at the littler powers. We only look at the highest one. Just wait, let me get through it all. Now, what is wrong with letter G? There's no n squared on the top. So this fraction is what we call bottom heavy. It has a bigger power on the bottom. I want you to think about fractions that have bigger numbers on the bottom.
0.
The limit is 0. The limit is 0. When the fraction is bottom heavy, it means the denominator is bigger, which means the fraction is smaller. When the denominator is bigger, your limit is always going to be 0. If the bottom is bigger, it's always going to be 0. Now, what about H? No limit. Because that's not bottom heavy, that is top heavy. And when the top is bigger, it means your fraction is going to grow. Let's recap. If you are paying attention, you recognize how simple this really is. When you have a fractional expression like this, there are 3 things that can happen. You can have the same power on the top and the bottom. If you have the same power on the top and the bottom, then you just compare those 2 coefficients. So if you have 2n to the 8th over 7n to the 8th, whatever else you have, your limit would be 2/7. If the power on the bottom is bigger, the limit will be 0. If the power on the top is bigger, there will be no limit. Divergent. Period. Now, that's all well and good until we get to problem I. Because I is built differently. It looks different. I want you to think about this though, because you have the same rules applying. Look at the fraction in problem I, 2/3. Is that fraction top heavy or bottom heavy? Bottom heavy. And what did we just talk about bottom heavy fractions? The limit is 0. Period. Do not overthink it. Do not make it complicated. If the fraction is bottom heavy, your limit is going to be 0. Now take a look at J.
No limit.
That one's going to be divergent or no limit because your fraction is top heavy. Now K, okay wait, I've been talking about fractions.
No limit.
This is a decimal. Can we make that decimal a fraction?
Yeah. No
What would it be?
1.5 over 1.
Well, you could think of it, I guess, I wasn't thinking of it that way, but you could think of it as 1.5 over 1. I was thinking of it as 3 halves. Either way, it's top heavy, which means divergent. What about E?
0.
It's 4/5 or 8/10. That's bottom heavy, so the limit is 0. Megan, is your hand up?
Okay, but up here we have like 4/5. Why is that just like on F? Why is that just 4/5? And that's fine, but down here we can 4/5.
It's 0.
Okay, in F, it's 4n squared over 5n squared. And that reduces to 4/5, okay? I'm not taking 4/5 to a power. I'm comparing my n squareds over n squareds. All right, turn the page. That's some limit work. I would guess your bus quiz on Friday will have some limits on it.
Can you we run at that bus quiz while on the bus?
We all take it together.
We'll take it together.
Okay,
Your
all
bus.
right. Okay, all right.
Okay.
I can get it on my bus. Megan on my bus.
Oh,
Wait, Miss Wheeler. Sorry.
we have 3 buses and a shuttle. Okay,
Oh, I want to
Miss
show.
Ford.
A. I'm on page 64.
I have a question. How come these ones are like equal 2/3 or 4/5 but not? Is it because they match?
Yes. They're different kinds of problems.
I said I was excited though.
Okay, so here we go. Number A, or letter A, on 9.5, page 64. Find the sum of the following series. We have not done this, so I need everybody paying attention. I left on the board 5 formulas that I want you to have written down. Some of those you recognize. The first 2 you recognize. The rest of those you don't. So we're going to practice them right now. Our terms that we are adding up are these.
I know I have no self-control.
Maya, Bravo. We're going to add these up. Now, one alternative that you always have is to just get your calculator out and start adding, right? Negative 18 plus negative 13, you could do that. That would be a problem if I said, let's add up the first 1,000 of these terms. Because this sequence could keep going. You see how many terms there? We're adding 5. So I could keep going forever and ever. I don't think you want to start adding those up individually. We want to use a formula so that we have a shortcut method. So we're going to add these up. That's our direction. Add means sum. These S's stand for sum. If you want to add them, you want to find the sum. The directions say find the sum. You want to add them up. So we are going to use one of the S formulas for sum. Now, which formula am I going to use? That depends totally on what kind of numbers you have here. Is this an arithmetic set of numbers, or is it a geometric set of numbers? Arithmetic. It's arithmetic because how are we getting from term to term?
Add 5.
We're adding 5. And remember, when you add, it's arithmetic. Remember that from last week? Well, then get your notes out and look at it because you need to remember that. Arithmetic is when we get from term to term by adding. This formula is arithmetic, and this formula is arithmetic. Those are the only 2 arithmetic formulas. If you want to take a picture of those, you can. Those are the only 2 arithmetic formulas. Since the problem says find the sum, we are going to use this formula right here because that's the arithmetic sum formula. Remember, S means sum. These S's mean sum. Now, how many terms do I have in this list? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. So I am going to find the sum of 8 terms. N stands for the number of terms. So I'm going to find the sum of 8 terms. My formula says what? 8 over 2. What does this mean? First term, which is negative 18.
This would be eighth term.
It'd be a sub 8,
A sub 8.
which stands for the 8th term, which is 17. So that's 4 times negative 1. If you added all those up, all you'd come out with is negative 4. Let's look at the next one. All right? Now, the directions say add them up. We're going to add all these, okay? So we are going to be using an S formula.
Times it by 3.
To get from term to term, we are timesing by 3. And since we are timesing by 3, we do not have an arithmetic situation. We have a geometric situation. This is geometric, this is geometric, and this is geometric. Now, because we are adding, we know we're going to be using one of these, right? S, sum, add. But there's 2 geometric options. How do I decide which one? This one is only for infinite situations. Now you're thinking in your head, Mrs. Well, what do you even mean by infinite? I'd like you to just turn the page real quick and look at the problems in number 3. Do you see how at the end they have a dot, dot, dot? This one does not. This one says add up these 5 terms. In the ones in number 3, it doesn't say add up 5 terms, it says add this up forever, dot, dot, dot. That's infinite. If you know how many terms you've got, it's not infinite, so we're going to use this formula right here. How many terms do I have, boys and girls? 5. So I am going to say S sub 5. I'm using this formula right here. Because it's not infinite, there are 5 of them. Infinite means forever. Okay, what does my formula tell me to do now? Negative 2 minus negative 2 times, what's my ratio? What did you say I was doing? Times 3 to the 5th power over 1 minus 3. All right, so let's look at that again, make sure we're clear on where all those numbers came from. A sub 1 is negative 2 minus, that's in the formula, negative 2 times 3 to the 5th, because you said there were 1, 2, 3, 4, 5 terms, n was 5, and then the ratio was 3. Now, see these 2 negatives, Dave? What are these 2 negatives going to do? They're going to cancel. And what is this denominator going to equal? Negative 2. I like to do that before I type it in, because this can be a little wild and wacky. When I type it in, here I go. Negative 2, press my buttons. Negative 2 plus 2 times 3 raised to the 5th power equals. I don't need any parentheses, I don't need anything. I type -2 plus 2 times 3 to the 5th equals. And then divide that by -2. Did you get -242?
Yes. So the S sub 5 like doesn't go in the equation.
No, that's what we're finding. This is S sub 5 right here, the sum of 5 terms.
Let's get ready. I forgot to subtract 2.
Okay? Now, in the interest of getting through a little bit more, I want to skip down to 2A. Because it says, find the sum of the first 90 terms. Everybody looking at 2A? We're going to find the sum of 90 terms. Okay. Now wait a minute. What kind of sequence is this?
You add 3.
I add 3. And if I'm adding 3, then it's arithmetic.
Yes.
So I am going to use this formula right here. That's my arithmetic sum formula. I'm going to give you these formulas, okay? You need to decide which one to use when. So let's talk about this one more time. First of all, I know it's one of the sum formulas because the problem says find the sum. So then I look carefully at my set of numbers, and I notice that I'm getting from term to term by adding 3. I have to notice that. I know that when I add 3, it's arithmetic, and this is my arithmetic sum formula. Okay, so I'm adding up 90 of them. So how does that work? What's that formula tell me if I'm adding up 90 of them?
90 over 2.
90 over 2. Okay. 90 over 2. What's this?
-2.
That's the first term, which is -2. And what's this?
Would just be 8, 90.
Oh, shooty. That's a sub 90. Do I know, did they tell me what a sub 90 is? This is a sub 90, but I don't know what it is. Can I figure out a sub 90? How?
Use the verse.
Exactly, Jack. Very good. I need a sub 90 in order to do the problem. This isn't the answer. This is the number I need right here. So over to the side, I'm going to have to do this formula so that I have a sub 90. What does that formula say? A sub 90 will be what? -2 plus, what's my D? 3. And if n is 90, what would n minus 1 be? 89. So 3 times 89, I got 265.
Yes, ma'am.
Now, do not put a circle around 265. That is not the answer. What is 265? What was that? That's a sub 90, which is the number that has to go here. So then, the actual answer is 11,835. Anybody match that?
Yeah.
Okay, why did I want to do that problem? Because it forces us to use both formulas. The question actually was, what's the sum? But we needed this formula so that we could plug in that number, right? All right, let's try B. Next page, B. We got 0.1, 0.2, 0.4, dot, 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 n equals 12. The directions say, find S sub 12.
Multiply by 2.
So, I need S sub 12. I'm going to use this formula or this formula. Those are my only two formulas that would let me do S sub 12. Before I know which one, I got to figure out how I'm getting from term to term. Abby, how am I getting from term to term here, Abby? What am I doing? Okay, so if I add 0.2, I'll get 0.4? Does that work?
Oh, sorry.
I have to do the same thing here as I do here. So what am I doing? If I add 2, I'll get this?
Oh. No, I do not know.
Well, you need to figure it out, because it is not that hard.
I know. It's doubling.
It's doubling. And if it's doubling, we are multiplying by, not by 0.2. If I'm doubling, I multiply by 2, not 0.2. You guys, stop. If I said, Abby, if I said we're going, if you scored 10 on the last quiz, and we're going to double that, what would that be? 20. And how did you get that? Okay.
You times by 2.
Times by 2. Doubling means times by 2. So when the terms are doubling, I don't care if they have decimals in them. You're still multiplying by 2. Okay, gang, I'm going to say it one more time, and I hate to put it in these terms. I know you do not want to be in this class right now. I don't understand that at all, but I know you have other things you would rather be doing. But if you think it's bad in April, being in this room cooped up with me for 45 minutes, in June and July, when you're in this room cooped up with me for 3 hours every evening, you will really be wishing you paid attention
Wait,
now.
what's your date? Wait, so it's 5 days a week?
That's summer school.
5 days a week?
Could be 6. We do it Sunday nights too. So,
So, yeah, everywhere.
so we're going to be motivated to not have to do that. All right, so here we go. Here we go. On those beautiful summer evenings, when the sun is out and it's 80 degrees and you're wanting to be somewhere else, you'll be right here.
Wait, hold on. So you gotta go 6 days a week for 2 months?
It depends until we get done.
For 3
All right,
hours?
S sub 12. S sub 12. Which formula am I going to use since I am multiplying by 2? I'm going to use the bottom one. That's geometric. When you multiply by 2, it's geometric. So here we go. The sum of 12 terms. How do I start? What's this?
That's the first number. That'd be 0.1.
0.1 minus 0.1 times 2 to the 12 divided by 1 minus 2. 1 minus r. R was 2. Now I'm going to go ahead and just make that -1. So I'll take my calculator. 0.1 minus 0.1 times 2 to the 12, hit equals, and then divided by -1. I got 409.5. Let me type that again. Press my same buttons. Ready? You need help typing it in. 0.1 minus 0.1 times 2 raised to the 12. Your raised button is that button, remember? Equals, make sure you hit equals, and then divided by -1. Except it says add up 12. I mean, it tells you in the problem. They just didn't write out all 12. It says add up 12. Now, when we look at problem A, 3A, it just says find the sum. It doesn't say find the sum of 12 or 10 or 100. It just says find the sum.
It also says infinite series.
Yeah, the word infinite is there, but we can take that out. Let's look at this series. Is everybody looking at 3A? We need to add those up. It goes dot, 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 and the problem says infinite. So you're going to use this formula. That is the easiest formula of all. All you need to know is the first term, which we know, and R. Now what does R stand for? The thing we multiply by. So we have to be able to look at these terms and say, hey, it looks like I am multiplying by 1/2. If you take 1/2 times 3/2, don't you get 3/4?
I think so.
And if you do 1/2 times 3/4, you get 3/8 and so on. So the ratio is 1/2. So to find the sum of problem 3A, it's incredibly simple. It's 3 divided by 1 minus 1/2. Well, what is 1 minus 1/2? 1 minus 1/2. 0.5, 1/2, right? So we have 3 divided by 1/2. Isn't that 3 times 2 over 1? Which is 6. Now, I know some of you are completely baffled by that arithmetic. You've got a calculator, people. Do 3 divided by 1/2. Do 3 divided by 0.5. And you should get 6. Okay? One more. I don't know how much time we have. B. We have time to do one more. Let's do B. Take a look at the sequence. Once again, the directions tell you it's infinite. So you are going to use this formula because it says infinite. The only thing you need is the first term, which is 4. And the ratio, which as Bryce said, is the number we get, or the number we multiply by as we go from term to term. What am I doing here? Somebody said I'm dividing by what? -2. Now, I can't do division, I have to do times. So if I'm dividing by -2, that's the same as timesing by -1/2, right? So this is 1 minus -1/2. So I have 4 over 1 plus 1/2, because those cancel out. What's 1 plus 1/2? 1.5. So I have 4 over 1.5. Put that in on your calculator. Don't try to do more than you need to. 4 divided by 1.5. 2.67. If you want to get a fraction, do math, enter, and it says 8/30. You may answer as a decimal or a fraction, I don't care. The fraction's a better answer because it's not rounded off. Okay? Now, I know that some of the homework, we got kind of caught up today. Some of the homework was a little beyond you if you bothered to look at the homework because we hadn't really discussed it. So now if you want to go back and kind of look at some of those assignments, you'll be a little more clear on it. Tomorrow, we'll do just a couple of things and then do some practice quiz work. On Monday, we're going to do a little more catch-up and review, and I believe we'll have a quiz over all this on Tuesday. I will provide you with the formulas, though, so you do not have to memorize them, all those formulas, so you don't have to memorize them. Today, I am substitute.
Miss Ford.
Oh, yeah, Miss Ford.
Can me and Taylor take a test on Friday, second period? English test?
Take an English test.
Yeah, second period. Did you say like if we're gonna miss
Oh,
one?
yes, absolutely. Yes. So, okay, I need to write that down though, because I would don't want to turn you as absent. So, second period. Anybody else? Somebody else was doing something second period. Who was it? I need your permission slips. Oh, somebody was going to class second period somewhere. Oh, crap. Okay, so second period will be Taylor and Olivia.
Miss Ford, can I come somewhere next period today and take my test?
No. Take it after school. Use ninth period to study. Katie Roth. Okay, so I get a permission slip from you. Did I guilt you into going? I don't want you to go if you.
No.
I don't want to impact your grades.
No, I went and talked to Mr. Bulmer, and I wasn't missing anything Friday because we're watching a movie because there's so many kids who are going on the field trip.
Okay, so what about? Okay, but what about not seeing the movie? Are you going to have to write a paper about the movie or something?
No,
Are you positive?
today. Yeah, we're taking a test
Okay.
today, and then the movie's
Alright.
kind of like.
Okay. Okay.
Bye, Ford.
Bye, sweetie.
Hi.
Hello.
So I guess my mom's company used to like work with you Loft, and she was wondering if you wanted her to chaperone, if that was helpful to you.
Well, we have all our chaperones lined up, but
Okay.
she is perfectly welcome to go if she wants.
Okay.
We're loading at 9:30.
All right.
So absolutely, I mean, I have absolutely, we don't need more chaperones, but we could always use more chaperones.
Okay,
So-
I'll let her know.
All
Thank
right,
you.
that's great.
Mrs. Ford, did she say anything about the test coaches?
You know what, I have not even paid attention yet, let me double check and see.
Okay, cool.
I'm too frantic about my field trip and getting permission slips.
You know, my car keys like on the roof of my car.
Go get them. Come right back.
Morning, Mrs. Ford.
Good morning.
It really smells really nice. And it's a cute little flower. You know those like plastic balls with like the marble mazes that you gotta like twist all around? Yeah. Yep.
I like walked past and I
Entire
looked and
resource, and I was like,
so I was like, who did I know in first period are? So I came in like for a dance appointment, and I look at it and I see you sitting. I was like, oh yeah, yeah.
So
Okay.
Ben wasn't there, I didn't have anything to do, and I'm like,
No, I
alright.
didn't have first period before.
Yeah, but I don't know where he is. He might be in the theater helping clean up more, I don't know. But he didn't even check in with
I
me, so
have
he may not be here.
speaker and I'll have it tutored for my last point.
Okay.
It's on my
I would
book,
suggest you sit, Ben.
Okay, can you email it to me so that I can print it, because we need like a copy of it to put
Yeah.
in your file?
Yeah.
Let's do that. And then you'll be done?
Yes.
Okay.
All right, thank you.
And, you're not here ninth period, are you?
No, you can slip it under the door.
Okay. Thank you.
Uh-huh. If you email it to me, I'll print it.
Okay.
And I'm just like stressed. Like right now I'm more stressed than before I made my college decision because Emily had to make her college decision. Like literally
It doesn't matter.
I know it doesn't, but it's stressing me out.
It shouldn't.
I know.
Look what sweatshirt you're wearing.
Yes, I know.
You know you're attending
I know.
that college that's on your sweatshirt.
I know.
You don't need to care about anything else.
Oh, and
Especially
then
Emily, because Emily's not gonna decide until May 1st at 11:59.
No, I know. It's just like driving me crazy.
Nicolette went out to get something. Where is Nelson?
I haven't seen him this morning.
Yeah, I don't see him before this period, so.
He normally is in the library, but
Sometimes I'll pass through the hallway, like, you don't count on that.
Yeah.
Here.
yeah. Oh, they're doing sequences and series too.
So.
It's the worst kind
You
of
have
math
to
I've
take
ever
the
had
L
to
on
do.
that on the AP exam. If I take the AP.
If you would.
If I actually take the AP exam. It's not so that time.
No, what'd you say before that?
I'm gonna have to take the L on sequences and series. That was like, that was bad. That whole chapter 9. Not good. Not good stuff. I will.
Yeah, it was awful. Scad, quit emailing me.
Yeah, I emailed this lady and she said, please report today during to the cafeteria during periods 2 or 3.
Okay,
Yeah.
go.
Have fun.
You don't need to do that, Andrew?
No, I'm already set up.
Okay.
Is that going to take the whole period? Probably not.
You know the drill.
Can you do that?
No,
I doubt
not
it.
usually.
You won't need iPads.